Okay, let's go ahead and practice this and finish up our notes. If you have any questions, we'll go over it in class. Here, when people create codes for their cell phones, the first digits follow distributions very similar to to those shown in the table. I would like to take a second and tell you that this is relative probability. Relative probability, not frequency, which I almost wrote down. So this is from your previous page, relative, it says relative frequency. Maybe it is relative frequency or relative probability. All right, so this is where they've done studies, and then this is the outcome of like 30% of the time people choose one, right? So this is something that's not an equally likely outcome. You're using a table to be able to answer these numbers, and so that's where it comes in with this relative frequency or relative probability. We want to find the probabilities of these events. Event A is the event of the first digit being 1. And it gives it to us. This table says, hey, the probability of the first digit being 1 is 0.300, because they gave everything to 3 decimal places. So there you go. What is the probability of the first digit being more than 5? Well, if it's the probability being more than 5, that means we could use 6 or 7 or 8 or 9. What operation do we do in order to calculate the probabilities using the word or? So remember from above, from our third rule up here, up top, if we have the word or, we're talking about plus. It could be 5 or it could be 6. It could not be 5. It could be 6 or 7 or 8 or 9, right? Your probabilities get larger and larger and larger because now you have 4 out of all of those numbers that you could choose from. And so that's a large probability, right? So try and think about this in the real world, in the context, right? That's a large probability, which means it's going to get bigger and bigger and bigger, which means you should be adding those probabilities. As opposed to if I use the word and, it wouldn't work in this case, but if I was like, what's the probability of somebody's phone number in total having the number 7 and the number 6? That might be different. That would be a smaller probability than if somebody said a probability of 7 or 6, right? 7 or 6 means you could have 2 of those numbers and it's okay for what we're looking at, versus having both of them. That's a pretty small probability. It's getting smaller and smaller. So or is adding them because we're getting bigger, more likely to happen. All of that to say, we need to find the probability of 6 plus the probability of 7 plus the probability of 8 plus the probability of 9. You have all of those decimal values up here. 0.067 plus 0.058 plus 0.051 plus 0.045. All of those add together to be 0.221. What is the probability that the digit is an odd number? So that's the probability that it could be 1, or probability of 3, or probability of 5, probability of 7, or probability of 9. I would like for you to go ahead and grab all of those numbers from this table and add them up and tell me what they are at 3 decimal places. All right, so probability of 1 is 0.3 plus 0.122 plus 0.078 plus 0.058 plus 0.045. That should all add up to 0.603. That kind of makes sense that it's close to 50%, right? It's like 60%, so it's a little bit higher than that. And it's because half of our numbers are odd, right? So it should be about 50%. There's some sort of bias, or there's some sort of leaning towards more odd numbers than even numbers for some reason. But it makes sense. It wouldn't make sense if it was like a ridiculously small number. All right, find the probability that the first digit is 1 or greater than 5. So that's the probability of event A plus the probability of event B. Go ahead and tell me what that answer is. You should have gotten 0.30 plus 0.221, which adds to 0.521. The probability of not 1. Remember that the probability of not 1, which is the probability of not A, is equal to 1 minus the probability that it is A, right? If it's not 1, then it's all of the other probabilities added in there. So calculating that out, you should have gotten 1 minus 0.3, which is your probability for A, which is a total of 0.7. We're going to do 3 decimal places because that's how they gave it to us. We want to know the probability of an odd number, which is your event C, or, which is plus, a number larger than 5. You should have gotten, if you put that together, you might have done something like 0.603 plus 0.221. However, realize that you can be an odd number and you can be a number larger than 5, right? You can be 7 or 9 and you would be an odd number and a number larger than 5. So it's being accounted for twice in both of these, right? It's being accounted for in this probability and it's being accounted for in this probability. So these two events are not independent. These are not mutually exclusive. These are events that overlap in a way. And so you can't just add like that. We do have a formula that we will be learning in future lessons, but we are just focusing on something small today at the beginning of our probability unit. So right now, what I would like you to do is just list out what are the numbers that do fit for this, right? What is an odd number or a number larger than 5? Well, that's the probability of 1 plus the probability of 3 plus the probability of 5 plus, that's accounting for the odd number piece. And then now a number larger than 5 could be 6, 7, which accounts for both of them, 8 because it's larger than 5, and then 9, which works with both of them. Adding all of those up, we should get 0.721. So just be very aware of the fact that if you have any events that overlap, that have things that occur in both of them, you can't just add their probabilities together. It gets a little tricky, and we'll talk about it in future lessons. Good job today.